Hey guys, welcome back. In this video, we are going to prove that derivative of cosine x with respect to x is negative sine x. And here x is an angle and this angle is measured in radians. Okay. Now we have from the first principle that derivative of this function y equals to f of x can be written as limit when h tends to 0 fx plus h minus f of x upon h. Okay, and this is the derivative definition from the first principle. Now we have that y is equal to f of x equals to cosine of x. Okay, and we'll put this in the equation to prove it using the first principle. So now we will have that derivative of y with respect to x, which is derivative of cosine x with respect to x, will be limit of h tends to 0 cosine of x plus h minus cosine x upon h. Okay, now from the angle formula we can write this expression, which has the form that cosine a plus b can be written as cosine of a cosine of b sine of a sine of b, right? So we can expand this using this formula from the angle identity, and we will have that limit h approaches to 0 cosine of x cosine of h minus sine of x sine of h minus cosine of x, right, divided by h. And I have already derived the proof for the very important limits involving sine and cosine, that if we have limit x approaches to 0 sine x divided by x is equals to 1, and we also have that limit x approaches to 0 cosine x minus 1 divided by x will be 0. Okay, and here this x is also an angle and this angle is in radians. Any trigonometric function that we use in calculus involving cosine x or cosine x or cosine t and all, these t and x are all angles which are measured in radians. That's very important that you should keep in mind. Now what we will do is that we can see that this cosine x and cosine x are common for this term. So we can collect the common terms here. Limit h tends to 0 cosine x, right, which is cosine h minus 1 divided by h minus sine x sine h divided by h. Yes or no? And now we know that this cosine x and this sine x, they don't have the h term, so they are independent of the limit, so limit does not apply to this. Even if the limit h approaches to 0, this cosine x will be cosine x only because it does not have the h terms. And same thing applies to sine. Only the limit applies to this part of the expression. Okay. So by distributing the limit now, we will get cosine x limit h approaches to 0 cosine x cosine h minus 1 divided by h minus sine x limit h approaches to 0 sine h upon h. And now we know that this expression is exactly this one and this expression is exactly this one. So finally what we will get, this expression is now 0 and this is 1. So this is cosine x times 0 is 0, whereas this negative sine x times 1 is negative sine x. Okay. Derivative of cosine x with respect to x is sine x, and which will also imply that integral of sine x with respect to x will be negative cosine x plus c. And this is also very important result, and this will be very handy when we differentiate the function involving trigonometry as well as integrating the function with involving the trigonometry. I hope you have enjoyed this video and understood this proof. and I'll see you in next video. Thank you.